Hello, welcome back to Live, where I do LeetCode Daily questions, raw and uncut. So let's get started. So we have a medium today. We actually haven't seen a hard for quite a while. Uh, yeah. So today's one is called letter tile possibilities. So again, you have n tiles, which is represented as a string, as we can see here, and on each tile it has one letter, tiles I, and they are all uppercase English characters. And well, also the tile's length is very small, so I think we are looking at some exponential algorithm again. So let's see. So return the number of possible non-empty sequences of letters you can make using the letters printed on those tiles. So number of
found some web results. I can show them if you ask.
sorry about that. So let's some examples. So we have, so if tiles is equal to this, the possible sequences are, well, like A B A A A B B A. Right. So it doesn't really matter um like the arrangement of the tiles, like on the provided string. What matters is like how many can we, like how many unique ones can we actually make. I think that's what it wants. um so well, one way to do it is to try out every possibility, and then like we can have a map that basically stores like we can have a set that stores all the scene patterns. And so yeah, so this is the brute force way, right? So let's say for AAB, we, well, what do we want to do? We want to try out every single combination, right? So um so we can have, like we can actually maybe ABC is a bit better to see, because like they're unique. So like you have the one letter ones, and then you have the two letter ones. So ABAC BC, and they're reversed. So that's, and then you have like the three ones. So uh, ACB and so on, and then like at the end we have CBA. There should be six here. Um, so what would the, like, how many operations do we need if the largest is seven? So um, so if the largest is seven, well, actually, how did I get, like how do I know that there are six here? Well, you can so if you have three slots, you have three choices for the first one, and then you have two for the second, and then you have one for the last one. So if we have seven, well, what is this here? Well, this is the factorial, right? So that means for seven, like when we have seven characters, it's just gonna be seven factorial, which is well, 4 is 24, 5 is 120, 6 is 720. I think it's like 5040, if I'm not wrong. Well, but my point is we have like 5,000 operations only. And well, what that also means is that, like, with all these combined, I think we will have around like maybe, well, we will have less than like 7,000 possible like sequences that we can form. And therefore we can definitely use a set to check uniqueness. uh yeah, the question is, how do we actually want to code this out now? Like again, this is like we have to use some recursion and stuff, or um yeah, like we need some way to actually get like all the permutations, well, like for all the different subsets as well, if that makes sense. So yeah, let's think about how we can get there actually. Oh, actually, now that I think about it, so let's say we have seven characters, so something like this. um and we are looking for like for four characters. well, we first have to do a 7 choose 4 here actually. So why do we do 7 choose 4? Like because we are choosing 4 characters, right? And there are 7 choose 4 amount of combinations we can choose. And in that we actually have like 4 factorial, because like there are factorial that we can try out. Um so what is that? 7C4. I'm just using my calculator now. Yeah, that's only like 480. So it's not too big. What about like 7C5? Yeah, so that's like 2.5k around. 7 choose 6 and 6 factorial. Yeah, so that's 7 choose 7 is 1, 7 factorial is 5040. So yeah, actually we're getting like more like 10k here, like around 10k different unique combinations. But um yeah, but we don't actually have that many like different like different combinations of tiles that we can try. So um yeah, so let's think about, I think like for this problem it's pretty obvious, like due to the small bounds, that it is going to be, well, a brute force solution. The hard part is definitely to code it out. So maybe we can go back to bit mask, which is a bit like the question 2 days ago. Uh, so, well, what do we want to do? We want to be able to choose, uh, like for each character. So, like, let's say, like for A, B, C, D, E, F, G, right? Um, we want to we want a way to represent which ones we are choosing, right? So, like if the bit mask is something like this, then we are only choosing the ones with set bits. So only D and F here. We're only choosing these ones. Well, and because we are only choosing these ones, I think in Python there's a iter tool that generates all the permutations for you. Uh, so you can just use that to generate all the permutations, and then we add that into a set, and then at the end we just check the size of the set, and we should get the correct answer. So let's get coding. I might have to search up the iter2 thing, like for permutation, but I think it should be fine other than that. So so yeah, let's get coding. Yeah. So we want a bit mask, like at first. So, well, actually we want to know how many tiles we have first. So number of tiles, well, it will just be a length of tiles. And for I in range, well, we don't want to loop through the number of tiles, right? Because we are looping through the bit mask. And let's see for this one, right? So for this case here, uh we have 7 tiles, and what is the largest number our bit mask can take? It'll be, well, all ones, right? And that should be, well, 1, 2, 4, 8, 16, 32, 64. So that would, like, if you add all of these up, well, what is the decimal representation? It would be 127, right? So that means we want to go from like 0, so like all bits are set to 0, all the way to, well, all ones. So we like in decimal representation, that would be 0 to 127, right? So what does that mean? Like we want 2 to the power of the number of tiles. So yeah, and then so after so that's gonna be our bit mask. Maybe we can name it bit mask. Maybe that's a bit nicer. So bit mask, and then actually, after doing the question on Saturday, I realized that I can just use bit operations to get which tiles we haven't seen yet, like, or like to get the to get the set bit for each of the mask basically. And actually, let me search up iter2 first. So yeah, let's see what it has there. Yeah, okay, so we just have to do, we have to import iter tools, and then we want to generate all the permutations. And actually, well, we can just try out. Yeah, honestly, let's just try out what happens first. Like, so I think that's how you use it. Permutation. And then tiles. Yeah, I'm just not sure whether it works on string. Well, string is technically an iterable, so it should work. But well, let's still print it first, and we can like let's try to see how that works, I guess. Okay. So it returns an iter object. So just turn it into a list. That'll work. Yeah. Okay. So it actually gets turned into tuples, which is quite interesting. I never knew that. I think I've only used iter tools like once or twice. So okay. So there we go. So we just have to generate the new string. I think it also works for list. So if we do something like split, well that's gonna give us the list, right? I think so. Let me see. Yeah, I forgot. I totally forgot what tiles, like what happens when you do split here. You have to if you don't put anything here, oh, I'm still wrong actually. Right. Well, we can do it some other ways, I guess. So we can just generate the string each time. So let's uncomment these. So what we want to do is we want to generate the new string. Oh, I think a list would be better. And I'm pretty sure, like, if I turn, that's how you do it. So if you do list, it turns your string into a list of characters, right? No. Yeah, I'm just trying to figure out the functions here. Yeah. Yeah, so if you turn it into a list, that will also work. Right. So we want a list on the current, like, we want a list of the tiles for the current bit mask. So we have so what do we have? We want the subtiles, I guess. And now while bit mask is not 0, we basically just want to do we definitely also need an index up here. So if bit mask modulo 2, well, if like that checks whether our least significant bit is 0 or 1, right? So if it is 1, we do want to get that tile, and otherwise we just don't do anything, right? But here we just just divide it by 2 and round it, and like when we divide by 2, we're basically shifting all the bits to the right ones. So I'll just draw an example maybe. So let's say we have like 101. Well, 101 is an odd number, right? Because, well, we have a 1 here. So that will be a set bit. And then when we divide it by 2, we are shifting all the bits. And we are, like, when we shift all the bits once to the right, it is going to remove the rightmost bit. So we'll get 10. So if we keep track of the index, so like the index will be 0 here. And like we'll shift once more. Eventually it gets to 0. So we know that for index 0 and 2, we have set bits, which aligns with what we want here, right? So that's just a very short explanation of how we can use bit manipulation on this. So we do this, and then of course don't forget about incrementing the index. So we should have we should add that to like the subtitles, right? So we want to append this tile in. And then what else do we need? We need a set. So unique patterns, maybe. So we can just use a set here. And then right, so after we have done this, we got all the tiles we want for the current bit mask. So we can just generate all the different all the different permutations. So we can do for permutation in how do we use it? Iter tool. Maybe we can do like from iter tools import permutations. Maybe that's a bit cleaner. So permutations, mutations. We want to input the list, which should work. So all the subtiles, and then we generate all the permutations here. We just want to store, like, we don't actually care about like what permits. Well, it is a tuple. So actually we do kind of care, because we can't put any mutable things in Python sets, but we can see that it generates tuples. So tuples are fine because they're immutable. So we just want to add that into unique patterns. And if that pattern has been seen before, because sets don't allow duplicates, it will just do nothing. So it's totally fine. And then at the end, we just want to return the length of unique patterns. I got 9. Because I have to make sure that we don't look at the 0. Like we don't look at empty sequences. Yeah, okay. So now it works. I think it should work. Okay, nice. It worked. And yeah, I think this question, like, again, we need to use bitmask, which is not the easiest to code up. You have to know that permutations exist. If not, like, you have to write it yourself, which is quite annoying. But otherwise, I think this question conceptually is not too bad. And yeah, thanks for watching, and I'll see you tomorrow. Bye.